Hello dear my friends, how are you? I hope you are best. Welcome to my channel. So this is my content, my topic today about which I give you information about semiconductor device. What is our I will complete guide you about semiconductor device. But first of all, if you are new, so please subscribe to my channel and press the bell icon. So I start my topic about semiconductor device. A semiconductor device is an electronic component that relies on electronic properties of a semiconductor material. Material for its function, conductivity lies between conductors and insulators. Semiconductor devices have replaced vacuum tubes in most applications. They conduct electric current in the solid state rather than as free electrons across a vacuum, typically liberated by thermionic emission or as free electrons and ions through an ionized gas. Semiconductor devices are manufactured both as single discrete devices and as integrated circuits, which consist of two or more devices which can number from the hundreds to the billions, manufactured and interconnected on a single semiconductor wafer, also called a substrate. Semiconductor materials are useful because their behavior can be easily manufactured by the deliberate addition of impurities known as doping. Semiconductor conductivity on the controlled by the introduction of an electric or magnetic field by exposure to light or heat, or by the mechanical deformation of a doped monocrystalline silicon grade. Thus, semiconductor can make excellent sensors. Current conduction in the semiconductor occurs due to mobile or free electrons and the electron holes collectively known as charge carriers, doping a semiconductor with a small proportion of an atomic impurity, such as phosphorus or boron. Greatly increases the number of free electrons or holes within the semiconductor. When a doped semiconductor contains excess holes, it is called a p-type semiconductor. P for positive electric charge. When it contains excess free electron, it is also called an n-type semiconductor. N for the negative charge, electric charge. A majority of the mobile charge carriers have negative charge. The manufacturer of semiconductor controls precisely of the location and concentration of p and n-type dopants. The connection of the n-type and p-type semiconductor from P/N junctions. The most common semiconductor device in the world is the MOSFET, metal oxide semiconductor field effect transistor, also called the MOS transistor. As of 2013, billions of MOS transistors are manufactured every day, and semiconductor devices are made per year have been growing by 9.1% on average since 1978, and shipments in 2018 are predicted for the first time to exceed 1 trillion, meaning that well over 7 trillion have been made to date. And main types are diodes. A semiconductor diode is a device typically made from a single P/N junction at the junction of a type and an n-type semiconductor. There forms a depletion region where current conduction is inhibited by the lack of the mobile change carriers. With the device is forward wave connected with the P side having a higher electric potential than the N side. This depletion region is diminished, allowing for the significant conduction. Otherwise, only a very small current can be achieved when the diode is reverse wave connected with the N side at lower electric potential than the P side, and thus the depletion region expanded. So friends, how is my topic? I hope you understand. Take good knowledge for this my topic. If you take good knowledge, also please subscribe my channel, press the bell icon. So now I am go to my new topic, take a laugh, and inshallah next topic is very special I create and just for you I create. So now I am go take your laugh. Hello my dear friends, how are you? I hope you are well. Welcome to my channel and this is my content, my topic today about which I give you information about power electronics. What is power electronics? I will complete guide you about it. But first of all, if you are new, so also please subscribe my channel, press the bell icon, so I start my topic about power electronics. Power electronics is the application of electronics to the control and conversion of electric power. The first higher power electronic devices were made using mercury ARC values. In the modern system, the conversion is performed the semiconductor switching devices such as diodes, thermistors, and power transistors such as the power MOSFET and IGBT. In contrast to electric systems concerned with the transmission and processing of signals and data, substantial amounts of electrical energy are processed in power electronics. An AC-DC converter rectifier is the most typical power electronic device found in many consumer electronic devices, for example television sets, personal computer, battery charge, etc. The power range is typically from tens of watts to several hundred watts. In industry, a common application is the variable speed drive VSD that is used to control an induction motor. The power range of VSDs starts from a few hundred watts and ends at tens of megawatts. The power conservation system can be classified according to type of input and output power: AC to DC, DC to AC, DC to DC converter, AC to AC converter, and in some history. Power electronics started with the development of the mercury ARC rectifier invented by Peter Cooper Hewitt in 1902, and it was used to convert alternating current AC into direct current DC. From the 1920s on, research continued on applying thermotrons and grid-controlled mercury ARC waves to power transmission. Lamb developed a mercury wave with grading electrodes, making them suitable for high voltage direct current power transmission. In 1933, selenium rectifiers were invented. Julius Edgar Lilienfeld proposed the concept of the field effect transistor in 1926, but it was not possible to actually construct a working device at that time. In 1947, the bipolar point contact transistor was invented by Walter Edward Brattain and John Bardeen under the direction of William Shockley and Bell Labs in 1948. And Shockley's invention of the bipolar junction transistor BJT improved the stability and performance of transistors and reduced costs by the 1950s, and higher power semiconductor diodes became available and started replacing vacuum tubes. In 1956, the silicon controlled rectifier SCR was introduced by General Electric, greatly increasing the range of power electronics applications. By the 1960s, the improved switching speed of bipolar junction transistor had allowed for the high frequency DC-DC converters, and R.D. Middlebrook made important contribution to power electronics. In 1970, he founded two power electronic group at Caltech. He developed the stable space of averaging method of analysis and other tools crucial to modern power electronics design. So friends, how is my topic today about which you like power electronics? I hope you understand. Take good knowledge for this my topic. If you take good knowledge, so also please subscribe my channel, press the bell icon. So now I am going to my new topic. Take care of it. The next video is very special for you. I will create just for you. So now you give me permission, I am going to my new topic. Take care, Allah Hafiz, and next video inshallah we will meet, and it is very special just for you I create. So now you give me permission, I am going. Take care, Allah Hafiz.